Hi folks, welcome to a YouTube live review for your final in college algebra. So we're going to be covering a wide array of topics, and I know I just did a review session on logarithms and exponential equations as well, so you can review that as well with what you're going to see here today. This is just kind of an overview of many of the materials that you might have forgotten along the way. And I won't hit on that logarithmic and exponential equations quite as much, but please take a good look at that as well heading into your final. So without further ado, we'll get started. Simplify the following expression as much as possible. Assume that all variables are positive, and we have the cube root of 64x to the 6th times y to the 16th divided by the cube root of 8x cubed times y in the denominator. Okay, so if we're going forward from there, what do we do? Well, we have that first part written down. When you see this cube root, it is multiplication all the way across, and that's different than addition. So what this allows us to do is rewrite this as the cube root of 64 times the cube root of y to the or x to the 6th, and then times the cube root of y to the 16th, all over the cube root of 8. The cube root of x cubed and the cube root of y. Okay, so taking a look moving forward from here, what do we have? Well, the cube root of 64, what number cubed gives you 64? Well, I'll write it this way just so we can see it. 4 cubed, 4 times 4 is 16, and then 16 times 4 is 64, so we have that. Now another way that might be easier for us to write the other pieces, let's write this as x to the 6th. When you see a cube root, that's just the 1/3 power. Just like a square root is 1/2 power and a fourth root is 1/4 power. That's essentially all we're doing right here. And then we have a y to the 16th raised to the 1/3 power. And then all of this is over, well, 8 is just 2 cubed, so we'll write that. And notice you have a cube root of x cubed. Those cubes, you could write it as x to the 3rd raised to the 1/3, but they'll cancel anyways, and you're left with just x. And then we have the cube root of y. So this is just y raised to the 1/3. Okay, so what does this do for us? Well, cube root of 4 cubed, we just mentioned how those things kind of cancel away there. X to the 6 to the 1/3, you multiply the exponents. So you get x to the 6 over 3, which we'll talk about in just a second. And then we'll get y to the 16 over 3, all over. Cube root of 2 cubed is just 2. And then we have an x, and then we have a y to the 1/3. Okay, so we can break this up into separate fractions. You can go 4 divided by 2. Notice x to the 6 over 3, we can rewrite that. That's just going to be equal to 2. So we can write that as x squared divided by x, which we'll simplify in just a second. And then we have y to the 16 over 3 over y to the 1/3. Now what you can do when you divide, well, 4 divided by 2, we can do that one pretty easy. But for the rest of them, we can subtract the exponents. And now x, you don't see a power there, so we can write that as x to the 1st. So this is x to the 2 minus 1 power. And then y to the, it goes 16/3 minus 1/3. Okay, so now we're ready to rock and roll and finish this thing off. And we have 2x. And then we get y to the 16/3 minus 1/3, so that's going to be y to the 15 over 3. And this makes 2x, and then we have a y to the 5th. And that is our final answer. Okay, I should put technically x and y cannot equal 0. So x cannot equal 0 and y cannot equal 0. But we won't be having you write that down, but just keep that in mind. The reason why we can't have them equal 0 because they were in the denominator in the original expression, but they're not in a denominator here. So keep that in mind when writing that final answer. Are there any questions? And if there are any questions at any point in time, please, there's a little chat box. Please feel free to ask the questions in there. So without any questions, we'll keep on moving. We have multiply the two rational expressions. We have 10n squared plus 23n minus 5 divided by 2n squared plus 5n plus 2. That's all in the denominator. And we're multiplying that by this rational expression. 2n squared plus 4n is in the numerator, and then 2n squared plus 7n plus 5 is in the denominator. So now, looking at this, it looks like we can factor these things pretty nicely. Okay. And if you don't know how to factor them right away, you could use the quadratic formula since all these are quadratics. Make sure you also know your difference formulas of cubes and quadratics as well. So you got to be aware of all that's going on with all those pieces there. So now let's kind of break apart what are some of the easier ones. Well, we have the ones with the 2n squared. The 10n squared might be a little bit more difficult. So the probably easiest one is where we see pluses everywhere. So you have, if you have 2n squared plus 5n plus 2 working on that denominator there, we have 2n and n, and we know they're both pluses because it's a plus on this last part, and then we have plus in the middle. So that tells us we have pluses everywhere. Now, how do we actually go about solving this thing? Well, in order to do that, we need to find two things where we multiply one of those two things by 2 and the other thing by 1, and we end up getting 2 as that multiplication. Well, notice if we put an m plus 2 here and an m plus 1, when we multiply that on out, you'll get 1n, and then 2n times 2n makes 4n, 1n plus 4n makes 5n, so this matches that little factorization there. In our other scenario, what do we have? We have 2n, and these are both pluses as well. Okay, so we need 5 and we need it to get to 7. The way to do that, we'll put an m plus 1 here and a 2n plus 5 right there. Now I put two factors up top. Actually, we could do it without the parentheses in that one case. Notice that both of those have a factor of 2n involved. So if I factor out a 2n, what are we left with? Well, we're left with an n from that first term to make 2n squared. So 2n times n makes 2n squared. And then we need a 2 because 2n times 2 makes 4n for that second term. So we're almost there. Now the real tricky one for a lot of people is this last bit. So let's take a look as to where we'll go from here. So we need to have a plus and a minus, and we need to figure out how it becomes positive 23. Well, we have to have our factors be 5 and 1. So it goes a 5 with the plus and a 1 with the minus, or a 5 with the minus and a 1 with the plus. But notice if I put 5 with a minus, any factor of 10, there's no way I'm going to get to positive 23. So that means the 5 will go here and the 1 will go here. Now it's the factors of 10 that can possibly work this out. Well, notice we need 5 times 5 will give us 25, and then if we subtract off, if we subtract off 2, that would give us 23. So if I put a 5n here and a 2n here, notice that makes 10n squared, and then you'll have the 25n minus 2n makes 23n, and then you have the minus 5, which we already talked about that occurring. So now we have some beautiful things happening, and it's time to cancel some things out. So when it's multiplication like this, the nice part is you can just write them all the way across in one numerator and one denominator. So you have 2n plus 5, 5n minus 1, times 2n times n plus 2, all over 2n plus 1, times n plus 2, times 2n plus 5, and times n plus 1. When you look at this, first thing, 2n plus 5. That will cross off with the 2n plus 5 in the denominator right there. Then we have an m plus 2, and so I'll cross it off going this way. That appears in both the numerator and denominator. And the remaining terms do not appear in the numerator and denominator both. And by the way, those values, when we cross those off, say we had a y equals here, that would be a hole in the graph. So keep that in mind as well. We're kind of piecing all these parts together at the end of the day. So you get 10n squared minus 2m all over, okay, so we got to do 2m plus 1 times n plus 1. So that'll make a 2n squared. Notice we get plus 2m plus another n that makes plus 3n, and then plus 1 Positive 1 times positive 1 makes a plus 1. And that would be our final answer. Okay, questions on that? Not seeing any questions, so we'll keep on moving. Now we're moving in from simplifying expressions to solving equations. You have linear equations, quadratic equations, all sorts. There's a couple ways to go about doing this. What I personally like to do is multiply both sides by a common denominator. That's usually the easiest way to get rid of things. So your common denominator will be the 2 and the 3. So notice, if we take 2 times 3 times all this stuff, so we go 3n minus 5 over 2 plus 4n. Remember, if we do it to one side, we got to do it to both sides. And then we'll do the 2 times 3. And the only reason we chose 2 times 3 because that's the denominators in both of those parts. So as long as you do it to both sides and make sure the whole side's in parentheses, you're going to be in good shape. Okay, so now where do we go from here? Well, we got to distribute this to both parts. Okay. So notice that makes 2 times 3 times 3n minus 5 over 2. Plus 2 times 3 times 4n. And I'm showing some extra steps here just to help out, hopefully. So we get 2 times 3 times 4n minus 1 all over 3. And then plus 2 times 3 times 5. Hey, alright. Okay, so the 2's will cancel in that first part. And then we have 3. That's a multiplication symbol, don't let your eyes fool you. 3 has to go times both of those terms. So that makes 9n minus 15. 2 times 3 times 4, so that'll make 6 times 4, which is 24n. Hey, alright. Okay, so in the next part, the 3's will cancel, and so then the 2 has to be distributed to both of those terms, and that's usually the most common mistake is people forget to distribute. Plus 2 times 3 times 5, so that's what, 6 times 5, which is 30. Alright. So now we have to get all our terms onto one side. So the way we can do that first, notice you have a 9 and a 24n, that makes a 33n. And then we'll take this 8n and move it to this side. So the way we do that was we subtract the 8n. Okay. Now I'll box out the numbers here, and then we have negative 2 plus a 30. So negative 2 plus 30 is 28, and then we got to ship this 15 on over to this side, so that makes plus 15. So what does that do for us? 33 minus 8, what is that? 25, I believe. So 25n. 28 plus 15, that's 33, 43. So that gives us a final answer of n equals 43 over 25. Okay, questions on that? So you can kind of see how those work out. Big thing with fractions, don't get scared, just multiply by the common denominator and you'll make it a nice easy thing to solve. Alright, so moving forward into from linear equations to a linear inequality. How do we go about doing that? Well, it's pretty much the same song and dance. There's not much to do here other than, so if you see 10v plus, now once again we got to remember to distribute. So we take the 5 times each of those, so that makes 25 plus 5v is greater than 4v plus 3. So now you want to get all the v's on one side. Okay? So if we get all the v's on one side, what does that do? Well, we already have 15v, but then we'll subtract the 4v over to this side. And then we have 3, and then we have to subtract 25 over to the other side. Now subtraction and addition do not change the inequality, but if we divide or multiply by a negative, that's when we change our inequality, which direction it's pointing. So keep that in mind when we're working these problems. So this makes 11v is greater than, that looks like negative 22. And so that means v is greater than negative 22 over 11, or v is greater than negative 2. Okay, that would be a solution. Another way for us to write this, oftentimes we have to write in an interval notation. So notice v is greater than negative 2, so that means we have negative 2 as our starting point, and we go all the way to positive infinity. Now if you struggle to see that, what I'd strongly suggest doing is taking a number line, put negative 2, put your open circle there. Now which direction, if v is greater than negative 2, for example, 3 is greater than negative 2. Notice it appears on this side, right? And so that would work, and so that's the side we're going to shade in our inequality. And sometimes that helps people to figure out what interval. Notice it's negative 2 all the way to positive infinity, going right there. Any questions on that one? Once again, there's a chat box. If you have any questions at any point in time, just put that question in there. If you aren't understanding a problem, I'll be happy to help once again. Okay, so for our next one, we want to find all real solutions of the equation 1 plus 7z plus z squared equals 0. So this might freak us out a little bit because they're z's and not x's, right? But it's no difference. There's a quadratic formula, and I'm going to put it in terms of z's this time. So you have az squared plus bz plus c equals 0. These are foolproof in terms of as long as you know what numbers to plug in and all that stuff, it'll work every time. So your a, b, and c are constants, so that means you can plug in and solve for z in this case. Notice it is equal to 0 on the right hand side, and so your formula goes negative b plus or minus square root b squared minus 4ac all over 2a. So that's what a lot of people do. They sing the Pop Goes the Weasel song, so they know it. So now we just have to figure out a, b, and c. So notice we gotta do a little bit of a rewrite. This is 1 times z squared. That's the tricky part that most people forget about, plus 7 times z plus 1 equals 0. So a equals 1, our b equals 7, and then so that a equals 1 came from there, and then the c equals 1, just so you can see which parts they're coming from is right there. So z equals negative b, so that's negative 7, plus or minus the square root of, we're going to square that 7, so 7 squared minus 4 times a, which is 1, and times c, which is 1, all divided by 2 times a, which is 1. So our z equals negative 7 plus or minus the square root of, that's 49 minus 4. 49 minus 4 makes 45, all divided by 2. Okay, so in terms of numbers of solutions, we actually have 2 solutions, and so they are the first solution being negative 7 plus, negative 7 plus square root of 45 all over 2, and then negative 7 minus square root of 45 all over 2. And that's it. Any questions on that one? If so, as I said, don't hesitate to always ask just during the process. You're more than welcome. If you got lost in a part, just let me know. So moving forward, we're dealing with quadratics. So find a formula for the quadratic function whose graph has vertex negative 1, 1 and y-intercept negative 6. So sometimes you can write it out as the ax squared plus bx plus c, but what I would strongly recommend in this case, so you have a vertex, usually you can write these things. First off, let me give you a drawing in terms of what's going on. So you have a vertex at negative 1, positive 1. So negative 1, positive 1, and a y-intercept of negative 6. So something like, let's say negative 6 is there, and let's say this is positive 1. And we know since this is a vertex and we got to hit this point down here, the graph has to look something like this. So it's telling us we're going to have a negative value somehow, some way. Okay. So now the form to try and work with, and I'll show you how we can relate it back to the other, is y equals a times x minus h, the quantity squared, plus k. And where hk is the vertex. Okay? So getting an idea as to what's going on here, we can plug that in. First off, we have the vertex. So this is a times x minus our vertex is negative 1, positive 1. That just came right there, just reading that. So x minus, we'll put in the negative 1 squared plus our k, which is positive 1. So this means our y equals a times x plus 1 squared plus 1. So now how the heck do we go from there? Well, we have a y-intercept of negative 6. So now we know if y-intercept is negative 6, that means 0, negative 6 is on the graph. Okay, so we want to solve for a. And so we're going to use that point 0, -6. So that means -6 is the y. We get x is 0 at that point. And hopefully we can solve for a. So notice this makes -6 equals a times 1 squared plus 1. Well, that's going to mean we can move this 1 over to the other side. That makes -6 minus 1 is -7 equals a. So at the end of the day, now we're ready to have our formula for our quadratic. It's y equals -7 x plus 1, the quantity squared, plus 1. Now if you wanted to do it a different way, so that's one method. So say you have a solution that wants it in the ax squared plus bx plus c form, right? So if that's the case, then we have to take -7 and multiply by, well, what is x plus 1, the quantity squared? That's x squared plus 2x plus 1, and then plus 1. So notice this would be the same thing as y equals -7x squared minus 14x minus 7 plus 1. And so that would give us another format for this final answer. Is -7x squared minus 14x and then minus 6. Both of those represent the same thing. Okay? So it's just working with those and trying to manipulate our answer in the format we want. Okay. Moving forward now, we want to find the point on the x-axis that is equidistant. What does that mean? Does anyone know what that means? So equidistant, what does that mean? From the points -1, 5, and 6, 4. So I'll draw a graph. See if you can tell me what equidistant means. You can post it right in that chat. So we have -1, 5. Something right there. And then 6, 4. So 2, 3, 4. I'll just say it's right here, and then 4. Okay, so let's just say this is -1, 5. You don't have to be as exact as I am right here. But say you have those 2 points, right? We want to find, oh, I'll use pink. We want to find some point, I have no idea where it is, but some point that makes this line and this line equidistant, means same distance. And what we know about this point, we'll call it, let's say a comma 0. We know the y value is 0 just because of the fact that we're on the x-axis, right? And that came from right there. So we want that to be the same distance. I'm not saying this is to scale whatsoever, okay? But so how do we do that? Well, the distance formula is given by the square root of x1 minus x2, the quantity squared, plus y1 minus y2, the quantity squared, equals the distance from x1, y1 to x2, y2. Okay? So that's the formula we're going to want to work with. But now we have to see, okay, two parts are being equal. So this distance we can find, right? So we can go square root of, notice that goes -1 minus a, the quantity squared, and then plus 5 minus 0 squared. Okay, and this should be equal to the other distance happening over here. So this distance, which would be 6 minus a, the quantity squared, plus 4 minus 0 squared. Now how the heck are we going to solve for these things? Well, first off, we can kind of simplify the inside a little bit. Notice we're just having a perfect square again. So this would be 1, 2 times the product of those two values. So that would be 2a. So 1 plus 2a plus a squared. And then 5 squared is 25. Right? So then from there, we want to see what's our other value. Well, same thing, we're completing a perfect square here. So you get 36. Now minus a times 6 times 2 makes minus 12a. And then plus a squared. And then plus another 16. So brushing that up just a little bit, we get the square root of, we'll put the a squared in front, plus the 2a, plus 26 over on this side, equals, this would be the square root of a squared minus 12a, and then, what do we have? 36 plus 16, I believe that's 52. Okay, so what do we do from here to solve this thing? Well, we could take both sides. Since we have a square root on both sides, we could square both sides. Now what does that do? So that makes our new equation, and we'll write it over this way. You get a squared plus 2a plus 26 equals a squared minus 12a plus 52. Now notice you have a squareds on both sides. So since they're the same, we can cancel those. And you have 2a plus 26 equals negative 12a plus 52. So let's move the negative 12a over to this side. That makes 2a plus 12a equals. And then we'd have to subtract the 26 over on the other side. So 52 minus 26. Okay. Oops. And then moving that forward, we get 14a equals 26, it looks like. And that means a equals 26 over 14, which is the same thing. Both of those are divisible by 2, so that'd be 13 over 7. And so the point, actually, I'll write it up top here. The a value, remember that's the x value, it's 13 over 7, and then this had to be 0 because it was lying on the x-axis. Questions on that one? I know that's kind of a tricky one to see, but hopefully that gives you a good idea in terms of distance as to what's going on there. So now, moving forward, complete the equation of the circle centered at 3, negative 8 that passes through negative 12, negative 11. Okay, if we have to do this one, the thing to remember here is x minus 8 squared plus y minus k squared equals r squared, where hk is the center of the circle, and r is the radius. Okay, so that means we can work this out really quick in terms of the start. You have the circle centered at 3, negative 8. So that means we have x minus 3 squared plus y minus negative 8 squared equals r squared. So now we need to figure out r. We could do one of two things, actually. You could plug this in, this negative 12, negative 11, into our formula and solve from there. Another method to solve for r is use the distance formula. We just talked about that, so I think it's a good habit to get into. So our distance formula, remember, we subtract the 2 points. So you go 3 minus a negative 12, and we're going to square that, plus negative 8 minus a negative 11, and we're going to square that. So what does that become when we take a look at that? Well, first off, we have 15 squared, so that means this should be r equals the square root of 225 plus negative 8 plus 11, essentially, so that's 3 squared, which is just 9. Okay, so that means r equals the square root of 234. So that means our equation for our circle is x minus 3 squared plus y plus 8, the quantity squared, equals the square root of 234 squared, which when you square the square root, gives us just 234. And that is our final answer for that one. Alright, moving forward. Find the equation of a line through the points 2, 7 and negative 4, 3. So an equation for a line that we might want to use is y minus y1 equals m times the quantity x minus x1, where m is the slope. That is, m equals x2 minus, or x2, I'm sorry, that's y2 minus y1 all over x2 minus x1. And x1, y1 is a point on the line. This is probably your easiest format to find a solution. So the first thing we'll need is m, and we have 2 points, so that's not going to be too bad. So we go 7 minus 3. Those are the difference in the y values. But since we chose 7 as our y2, that means our x2 has to be 2. So 2 minus negative 4. So notice that makes 4 over 6, or 2/3. So now we just pick a point. It doesn't matter which one you use, it'll work all the same. So we get y minus, so our y1, what we used before, will just kind of remain consistent, was 3, equals m, which is 2/3. Now since we chose that second value to be the y1, we need the x value has to be the negative 4 involved there. Okay, so now this would be a good final answer. Now let's say you had to simplify it where you have y equals. Well, that's not too bad either. We can go 2/3 x plus 4, right? And add that 3 on over to the other side. So what does this make? This makes y equals 2/3 x plus 8/3. Right? In order to add the 3 into that, we'll make it something over 3. Well, what over 3? Well, we have to multiply both parts by 3, so that's 9/3. So this makes y equals 2/3 x, 8/3 plus 9/3 makes 17/3. And you're done for that problem. Questions on that one? Don't see any questions, so we'll keep on chugging along. So now we want to find a solution to the system of equations 2x minus 3y equals 5, and then x plus 2y equals 1. So you have a couple ways of doing this. You could do substitution, solve for x, and then substitute it into that first equation. So that would probably be the easiest method. I'm going to do something slightly different. I'm going to multiply everything in equation 2 by negative 2. Just to show people the less familiar method. If you want to see the first method too, I'm happy to show you. You just ask and I'll go about showing you both ways. So notice now, when we multiply the whole bottom by negative 2, that makes negative 2x minus 4y equals negative 2. Now we can sum both equations. Okay, to give, what does that give us? Well, we'll get 0x, which is good. We want to get rid of that. Minus 7y equals 3, I believe. Let me sum that. Okay, so that means negative 7y equals 3, which tells us that y equals negative 3 over 7. So now you can pick the equation you want to plug that into. Well, I'd say the second one would probably be, and so the second one, because you have just x times 1. So notice we get x plus 2 times the negative 3/7. Oops, that's a 7. Equals 1. So notice that means x equals, we can add the negative 6/7 over there. So x equals 1 plus 6 over 7. So 1 is 7 over 7. So 7 over 7 plus 6 over 7 equals 13 over 7. So that means the solution to this, our x value was 13 over 7, and our y value was negative 3 over 7. And we have our desired solution right there. Okay, moving forward then. Let's start to get into some other stuff that might be a little bit trickier. Another way, just an FYI, so use the graph below to calculate the following. We have f composed with f of 3. Another way you might see this written, I just want you all to be sure, is just how you see it right there. So if you see a little open circle, that's telling you composition of functions. So how do we go about doing this? Well, first we need to find f of 3. So the f graph is the blue graph. And so now the 3 is the x value. So right here, where this x equals 3, we want to find what is the y value that corresponds to that. Okay, well, it looks like y equals 2. So notice we have f of 3 equals 2. Okay, so that means we can replace f of 3 equals f of 2. We just replace that whole inside with 2. Okay, so now we need to figure out f of 2. Well, so that means we need to go where x equals 2 and figure out the y value there. Since we're dealing with the f function, we're good. Okay, so now what's f of 2? Well, it looks like that just equals 4. So f of 3 equals 4. Questions on that? So now we're going to do the same thing for g. G of 3. So we already have that line for x equals 3. We've got to now find where it intersects the g graph, which is the red graph. So it intersects right there, and now we need to look at the y value according to that. So the y value is equal to 1. So we have g of 3 equals 1. So that means we are now looking at g of, we replace that inside where we saw g of 3 now with 1. Okay, so we need to find g of 1. So we'll draw a line where x equals 1 and find when it intersects with this red graph for g. And it looks like g of 1 equals 3. And so g of 3 equals 3. Okay, so something a little bit more interesting. F of g of 0. So notice now, our x value equals 0 right here. So this should be, g of 0 is going to be what? Actually, I should draw that line on up. Looking for g of 0, that's that red line up top. So g of 0 actually equals 4. And let me write that up top here. G of 0 equals 4. So we find that this is f of 4. Alright. Now f of 4, notice it's both the blue and the red at that point, that equals 0. So it doesn't always happen, but in this case, f composed with g of 0 equals 0. Now what about g composed with f of 0? Well, first off, we just saw on the graph, I was kind of jumping ahead a little bit. So g composed with f of 0, well, f of 0 equals 0. So we have f of 0 equals 0. So you get g of 0. And we just found that g of 0 equals 4. And so we get a final answer of 4 on this one. Questions on that one? So you're seeing how to use a graph, you're seeing composition of functions. So basically A, B, C, and D too. You could have said B was g composed with g of 3. Make sure you're just familiar with this notation as well. F composed with g of 0 and g composed with f of 0. Okay. Alright, moving forward then. Decide whether each of the following 8 graphs represent y as a function of x. If so, enter yes under the graph. Okay. Otherwise, you're going to say no. So what do? Well, we check this with a vertical line. Everything we're checking at every single point, you can kind of, don't let your eyes fool you, that was supposed to be a vertical line. But a vertical line can hit the graph at most once. And so the first case is yes, and then it passes the vertical line test. What does that mean? A vertical line hits it at most once. And from here on out, I'm going to call it VLT. So now when you look at this one, how many times is a vertical line hitting the graph? Well, notice any vertical line that I draw hits the graph only once. And don't let your eyes fool you, that is a vertical line. And so this second graph is yes, because it passes the vertical line test. What about this next one? Well, notice, oh, I hit it once, but I don't hit it anymore. Hit it once. Oh, look right here, I hit it 0 times, but that's still fine. It hits it as most once. Same thing here. Same thing there. Same thing for each of these points. There's no point that stacks on top of one another. And so this one is also a function. Yes, it passes the vertical line test. Okay, so for our next function, or equation I should say, it's passing in all these points, but uh-oh, this one vertical line, there's 2 points that lie on that same vertical line. So this is no. It fails the vertical line test. Okay. Same thing right out the gate on the next one. We have this vertical line, and notice that's hitting the point, in this case is even 4 times. So this one's no, fails the vertical line test. On our next one, we have a horizontal line, and if you look at a horizontal line, no matter where we draw our vertical lines, it's going to hit only once. So this is yes, it passes the vertical line test. For our next one, we're looking good so far, looking good so far, looking good. Uh-oh, right there. And this is the only part where we have a problem, just those 2 points, but all it takes is 2. This is no, fails the vertical line test. And last but certainly not least, we go right out the gate. We can put that point there and that point right up above. We see that this fails the vertical line test. So they're functions when you saw yes, and they're not functions in terms of x when you see the no fails the vertical line test. Okay, so moving forward, let's try another one. This one's kind of tricky, and I'm going to write it actually a different way. So just so you can see, what they're actually asking is this m composed with O of x times n of x. Okay, so the same thing is what they're doing. So this is m of, well, what's O of x? Well, it's square root of 2x plus 8 times n of x, which we'll deal with in a second. So this thing is equal. What does that mean? Well, it means the square root of 2x plus 8 is going to go in wherever we see an x, because notice how it replaced that x right there. So it's going to replace the x in the m function. So that means we go 3 times the square root of 2x plus 8, the quantity squared, minus 5. Right? And then times n of x, which is 3x. Okay, so this is n of x for that part. Okay, so this means we get 3 times, well, the square root of 2x plus 8 squared is just 2x plus 8 minus 5, and then all that's going to be times 3x. Distribute the 3 to both parts, so we get 6x plus 24 minus 5 times times 3x. And so notice that makes 6x plus 19 times 3x. So what is that going to make? That makes 18x squared. And then we'll have plus 57x, I believe. And that's our final answer. Questions on that one? So I know we're kind of hustling and bustling on through here. Let's see. In the next one, we want to find the domain of the function f of x equals 13x over the square root of x squared minus 3x plus 2. So there's two restrictions here that we got to watch out for. So first off, we can have the square root of x squared minus 3x plus 2. That can equal 0. And then the other thing that we got to watch out for is x squared minus 3x plus 2 has to be greater than or equal to 0. Well, notice if you square both sides of this other one, you get that x squared minus 3x plus 2 cannot equal 0. So the simplest way for us to approach this is you could drop the equal to. So what we're going to look at is x squared minus 3x plus 2. Rather than greater than or equal to 0, we'll just say it's greater than 0 because that avoids the not equal to 0 part. Okay, so we can look at this, and you can see right away what we usually have to do is find critical numbers, but this thing should factor, I believe. So you go x minus 2 and x minus 1 is greater than 0. So we have these critical numbers when x minus 2 equals 0 and x minus 1 equals 0. And so that means x equals 2 for this part, and that means x equals 1 for that part. So now, here's what we'll do. We'll mark down 1 and 2. And so notice that means we go from negative infinity to negative 1 for this interval. We'll go from 1 to 2 for this interval, and 2 to infinity for this interval. Okay, these are your x values. What we want to find out is the sign of x minus 2 times x minus 1. So if you pick a number, say negative 5, that's in this interval, negative infinity to negative 1, when you plug that in, you'll get a negative and a negative, which makes a positive here. If you pick a number between 1 and 2, say 1.5, that makes a negative and a positive, which means this middle part is negative. Okay, and then between 2 and infinity, you can pick a number like 7. It doesn't have to be 7, anything that fits inside there. So you'll get a positive and a positive. So 7 minus 2 is positive, 7 minus 1 is positive. So that makes a positive for that part. Okay, so notice when we actually go about the solutions, we don't want to include 0, so we have open circles, and we want to go in the positive directions. So we're getting, our solutions are these two intervals. And notice they're already written for us. So the solution is negative infinity to negative 1, and then we want to union that with 2 to infinity. And there we go. Any questions on that piece? That's tends to be a bit trickier. I upped the game a little bit, making sure you can understand the difference in domain, especially when we have two things going on at once. So if you do have questions, always feel free to ask. Alright, so fun times, now shifting. Now in terms of these are all just horizontal and vertical shifts. We aren't doing the stretches or anything like that, or yeah, stretches or compressions or anything like that. And you can see it by the way this thing is decreasing 1 unit, or increasing I should say if you go from left to right, increasing 1 by 1 and then decreasing 1 by 1, and that's happening in all these graphs. So everything excuse me, everything is the same. So what that allows us to do is we can put a focal point then on our vertex. So our vertex is 1, 1. So what did this do? Well, if you take a look at this graph, so if this is f of x, y equals f of x, right? Notice the vertex now is at which location? Well, our y value is 0 and our x is 1, 2, 3, 4. So this is 4, 0. So in order to get to this graph, what do we do for the original? Well, we shift down 1, and to the right it'd be 3 more units, right? Because we started at 1. Okay, so in order to do that, what do we do? Well, the shift that's horizontal goes inside the F, and the shift that's down just goes outside as a -1. So now to the right, it's kind of tricky. Usually you'd think positive, but it is actually a negative. So you go f of x minus 3 minus 1, and hopefully that appears in our list, and it does. So A is this one right here. Okay, so taking a look now, let's look at our next vertex. So we have our next vertex is at 1, comma, looks like 3. And all that did from the original graph, this is shift up 2 units. And so that means this graph should just be f of x, because we don't shift left or right or there, and then we just put a +2. And hopefully that's in here, and yes it is. What do you know? And there's the graph B. Okay, C. So notice we have 0, 3. So this is shift left 1 and up 2. So notice we're still going to have the +2 on the outside because that's a shift up 2. Now though, to shift left we go plus, and then we're going 1 unit, so we'll put a 1 right there. And so that means we have y equals f of x plus 1 plus 2, and so C should go right there. And the other ones are just trying to fool you. Okay? Questions on that? So seeing the transformations, how we work those. The main thing here, we had a vertex, so that was nice in terms of this, and it's no vertical stretch or compression. And you can check that just by the rate at which it's decreasing or increasing. Okay? Alright. Ooh, now we're getting into some other good stuff. So the graph shows, graph below shows the position of a car in miles from Gackle, North Dakota, as a function of time in minutes. Find the car's average rate of change, or average velocity, essentially, over the following intervals. So what are we doing? Well, what we're doing, oh, it even gives us the points here. That's nice. So we have a point here, and we have a point, so we want 57 to 104. And what we're going to do to find the average rate of change, here's what you're doing. You're just drawing a line. Average rate of change just wants you to find the slope. Okay? So remember, we already talked about the slope. We have the slope equals y2 minus y1 all over x2 minus x1. Or you can do the f of b minus f of a all over b minus a. Right? So this is the same thing as f of b minus f of a, because we have a function here, all over b minus a. Alright, same song and dance. But so now we have the two values. Okay, so what's the y values in this case? Well, y value goes 106.8 minus the other y value is 63.8. Notice that came from right there and right there, all divided by 104 was the one associated with 106.8, and then 57. Okay, so now what does that equal? Well, 106.8 minus 63.8, I believe that's 43, right? Yeah, I believe that's 43. And then 104 minus 57, that's going to be what, 47, I think. So 43 over 47, and this is a function of time over minutes, and oh, miles. So this is miles per minute. Okay. Now, as we do 68 to 104, let me do this in a different shade. Let's go with the dark blue here. So I go from here to here, and luckily, look at this, it's already a straight line. So it's just going to be the slope of this line. That's all we're doing. Okay. But so notice this one, it looks to be a little bit steeper, so it should be a little bit higher than what we had before. And we can do this same thing, 106.8 minus, the actual number is 63.8 once again. The only difference that we have here is that when we take 104, we're going to subtract 68 this time. Okay, So now, what does that make? Well, that still makes 43 up top, but down below we'll have, and this time we'll have 36. And notice that's a number greater than 1, so that's a little bit steeper, a little bit faster of a ride in terms of what's happening there. Okay. Questions on that? Average rate of change. You're just doing slopes of secant lines, that's it. So you pick 2 points on the curve, go from there. Alright, so enter yes or no in each answer to indicate whether the corresponding function, so we have to pass the vertical line test first, but after we pass that we're trying to determine if it's one-to-one. And so the big check is the horizontal line test. Which I'll abbreviate HLT. So notice we're working, everything is going hunky-dory here, we're pretty good. Horizontal line test. Uh-oh, we hit it once and then we hit it a second. We actually hit it infinitely many times here, but so in this case we end up having multiple points, so this fails the horizontal line test, so this is not one-to-one. And so the reason why it fails the horizontal line test. And so if you're given a function, it helps to have the graph, if you can draw the graph or whatnot. And so knowing those transformations of functions is also useful, right? If you have an x cubed or if you have an x squared, right? Like for example, x cubed, that's going to be a graph that is one-to-one. X squared is not going to be one-to-one because it fails the horizontal line test, versus x cubed actually passes it. In this case, our next case, when we look, we're good on that level, but when we get to this middle part, notice we failed the horizontal line test right here. Okay, so no, in this case we fail horizontal line test. Now looking at this next one, this is kind of neat. Now you might say, oh, well maybe it hits it twice right here, but notice it almost looks like it, but it doesn't quite do it. It only is hitting this graph once. And so this one is a yes, it passes the horizontal line test. And the same goes for this last one. We can check real quick and see that we're passing the horizontal line test. So this is another yes, it passes the horizontal line test, so we are one-to-one in each of those cases. So the horizontal line test is a key check for one-to-one. Or transformations of one-to-one functions. So as long as you know some basic functions, you can just look, is it a transformation of that, and then you're done real quick there too. Alright, moving forward. So we talked about one-to-one functions. Once you have one-to-one functions, you can start talking about inverses. So the first step to finding an inverse, so step one is replace f of x with y. Okay, so we'll do that here. Y equals 7x cubed plus 3. Step 2. Is solve for x. And so in order to do that, this is the hardest step. You get y minus 3 equals 7x cubed. You want to try and isolate that x in this case. So that means y minus 3 divided by 7 equals x cubed. And now we take the cube root of both sides. You get cube root of y minus 3 over 7 equals x, because the cube root of x cubed is just x. Step 3. We're going to replace x with f inverse of x. Then replace y with x. Okay, so if that's the case, notice that means that this becomes x goes to f inverse of x equals the cube root. Now we can replace y with x minus 3 all over 7. So our final answer that we'll put up here, cube root of x minus 3 all over 7, and you're done. Questions on that one? So now we'll get into some word problems here, or one word problem, and then make sure you take a look at those word problems from exponential logarithmic equations. There'll be a couple of those on your finals, so just be prepared. So we have the half-life of radioactive strontium-90 is approximately 30 years. In 1960, radioactive strontium-90 was released into the atmosphere during testing of nuclear weapons and was absorbed into people's bones. Ooh, fun times. How many years does it take until only 7% of the original amount absorbed remains? So first off, we're talking half-life, so we should have a pretty good idea as to what model we're looking at. And it's compounded continuously, since half-life doesn't decide, today I'm not going to decay. So you get your formulas A of t equals P e to the RT. Alright? So we're in good shape there. Now, where do we go from that part forward? So this means we have A of t equals P e to the RT. Well, we have a half-life is approximately 30 years. And some of you might know the formula involving half-life, but I'm going to show you a worst case scenario. So that means whatever the starting amount, if it's P, you're going to have 1/2 of P at 30 years. So you get P, E, and then we don't know R, but we have it's 30 years is when that occurs. Okay, so that's just that piece of information. So maybe we can find R, and that'll allow us to work with that last piece. So now, in order to solve for R, we're going to have to do a couple things. First, we got to get rid of P. How do we do that? We divide both sides by P. So if we take 1/2 P divided by P equals P divided by P, then we have an E, R, and a 30 here. What happens? Well, the P's will cancel on this side, and the P's will cancel on that side. So you're left with 1/2 equals E raised to the R times 30. Now, how do we go from here? Well, you can recognize that there's a log base E that we can take on both sides, or you can just take what we call that log base E is natural log. So natural log of 1/2 equals the natural log of E R to the 30. Now remember, this is a log base E, so essentially these two parts just kind of cancel, is what it looks like. But they're technically inverses of each other, so to be a little bit more precise. So our R value equals the natural log of 1/2 divided by 30. And I'm actually going to have to bust out a calculator. I don't know that one off the top of my head. So the first time I'll bust out a calculator. Natural log of 0.5 divided by 30. And it should be decaying, so it should be negative. So we get R equals, well, is approximately equal to negative 0.0231104. Technically, you should just leave that in the calculator because you're going to use it in a second, and that's what I'm going to do here, because rounding sometimes can cause some errors and issues. But so now, what does that mean? It means our model is A of t equals P times E, and then it goes natural log of 1/2 over 30. Just make sure all this is in the exponent, and then we have a t up there. Now, with that in mind, what do we have to do here? How many years does it take until only 7% of the original amount remains? So 7% is 0.07. So this is 7% equals 0.07. So keep that in mind. So that means we go 0.07 P, because whatever our original amount is, equals PE. Then we have natural log of 1/2 divided by 30 raised to the t power. Okay. So let's see if we can refine our ninja skills one last time here. Divide both sides by P. And so we go P divided by P. And we have an E natural log of 1/2 divided by 30, and then a T. And the P's will cancel on both sides. Okay? And we're left with 0.07 equals E to the natural log of 1/2 divided by 30, and then a t. Now here's where the fun begins. How do we get rid of that E? Once again, it's the same exact process. You take a natural log of both sides. Okay, so on the right hand side, things will cancel nicely, and you're left with natural log of 0.07 equals, and so we're left with just what's up in the exponent. Natural log of 1/2 over 30 divided by t, or times t. So now we divide both sides by that natural log of 1/2 over 30. So t equals, we'll have the natural log of 0.07 divided by that natural log of 1/2 divided by 30, which you could have just written, remember, as that negative 0.023104. So now all I have to do, though, if I'm using a calculator, I can take this information and divide it by the answer I previously had, and I find that t is approximately 115.1 years. And that's one heck of a long time. So 115.1 years. Whew. So that one took some work. But hopefully you see how it works out. We're just using the information that's given to us. Make sure you know the model, right? And don't worry, the equations will be given to you, so you'll see like what is compounded continuously. You just got to remember when to apply it, so and how to use it once you have it. Okay, so now simplifying logarithms. We want to try and calculate directly without using a calculator. Log base 9 of 3. And then plus log base 27 of 3. So what the heck is this stuff? So log base 9 of 3 plus log base 27 of 3. So this might be hard, trying to do them both at once. So what I'd recommend, try log base 9 of 3. And let's figure out what the heck this equals. So this is equal to y, let's say. Okay, so that means from our definition of logarithms, this is 9 to the y equals 3. Okay. This doesn't do us any help because they're different bases. You can use logarithms again to try and do it if you want to use a calculator, but this said without a calculator. So notice the way to break this down, though. 9 is just 3 squared. And 3 is just 3 to the first. So we can rewrite this as 3 to the 2y equals 3 to the 1. And then there's this one-to-one property that says, hey, you know what? We can just look, since those are the same base now, we can just look at the exponents. So 2y equals 1, and that means y equals 1/2. That's a beautiful thing right there. So this thing equals 1/2 plus we'll write log base 27 of 3, which we'll figure out in just a second. So now let's try and figure out log base 27 of 3. And let's call that equal to, say, z. What does that mean? Well, that means 27 to the z power equals 3. So that's not going to work for us. We need to get the same base because we're not using a calculator. Well, notice 27 is 3 cubed, so we can write it as 3 cubed to the z equals 3 to the first, and then that means 3 to the 3z equals 3 to the first. And what do you know? That one-to-one property says, hey, we can just look at those two pieces. And so that means we get 3z equal to 1, or z equals to 1/3. So therefore we have, this is 1/2 plus 1/3. Getting a common denominator there, that's 3 over 6 plus 2 over 6, making our final answer the beautiful answer of 5/6. Right up top there. And notice no calculator was used, nor harmed in the process of finding that calculation. So a couple last pieces just to bring this home, and then there's some other problems you should be working on too as well. Checking over that review for logarithms. Make sure you know, and what that deals with before, make sure you know those properties of logarithms really well. Same thing for exponentials too. So we want to determine the remainder when dividing x to the fourth minus 7x squared plus 2x minus 3 by this x squared minus 2x minus 3. So one thing to kind of look at, this is x to the fourth plus 0x cubed minus 7x squared plus 2x minus 3. So if we're dividing these two things, x squared minus 2x minus 3 divided into x to the fourth plus 0x cubed minus 7x squared plus 2x and then minus 3. Dun, 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 dun. So x squared goes into x to the fourth how many times? Well, notice that's going to be x squared, and then we have to subtract this whole thing. So x squared times x squared minus 2x minus 3 makes, and so that means we got to go here, here, and here. So we get x to the fourth, then it goes minus 2x cubed and then minus 3x squared. Okay, so this will, x to the fourth minus x to the fourth makes 0. So then you go 0x cubed minus a negative 2x cubed. That makes positive 2x cubed. And then you get negative 7x squared minus a minus 3, so that makes negative 4x squared. And we got to drop the 2x on down. So plus 2x. Alright. So x squared times what will give you 2x cubed? Well, notice that'll be plus 2x. And so now we have to do the same process. So 2x times x squared makes 2x cubed. 2x times negative 2x makes negative 4x squared. Hey, what do you know? And then 2x times negative 3 makes negative 6x. Okay, so 2x cubed minus 2x cubed makes 0x cubed. Negative 4x squared minus a negative 4x squared, that makes 0x squared. And then 2x minus a negative 6x makes 8x minus 3. And so notice we have, and I'll put in the plus 0x squared plus if you want. But so that means you'll put a plus 0 on the next term, and so that means this is 0x squared plus 0x plus 0. And you're left with 8x minus 3. And x squared can't go into, oh, and I should, yeah. X squared cannot go into 8x anymore, so our remainder of this thing, and a little bit crazier of a problem, is 8x minus 3. And you keep on going until your degree is 1 less than what you're dividing by every time. So keep that in mind for that one. Alright, last but certainly not least, write the following expression as a single logarithm. We have 2 natural log of x plus natural log of x squared minus 1 minus natural log of x minus 1. So the first thing to do, you see that 2 right there, that needs to go in before we can do anything else. So you need to use, that's the power rule. Right? And make sure you know all the laws of logarithms. They come in handy. Oops, x squared minus 1. Minus natural log of x minus 1. Okay, so now you see how this is a plus. The product rule states that we can combine these two into a single logarithm. So you go natural log of x squared times x squared minus 1 minus the natural log, and all these are equal, minus the natural log of x minus 1. And so this then becomes equal to this allows us to combine these two using the quotient rule of logarithms. So you get natural log of x squared times x squared minus 1 all over x minus 1. And notice now, here's where the fun begins. We do have a single logarithm, so we could be considered to be done, but just for kicks, x squared minus 1 is x minus 1 x plus 1. And so notice your x minus 1s would cancel, and you're left with natural log of x squared times x plus 1, and that is a final answer. Questions on that? So I don't see any questions, so please, I hope you can take this and use it for your review. Take a look at all the old quizzes and exams, and let me know if you have any questions along the way. I wish you all the best of luck, and have a good one, folks.